So straight after recording the previous one, I noticed this. If we're moving down, our tail disappears. It shouldn't be too difficult to fix. See, it's gone. In any other direction, fine, it's fine, it's fine. It's only when we're moving down that it does it. And the problem there is this. Okay, so if we look at any of the other sprites, we're working with 7 by 7, so that's actually the sprite. You'll notice that the tail is right at the bottom edge if we're going up. This one, it's on the left. This one, it's on the right. But this one, it's one away. So all I have to do is move this like that. Now, tail's fine, tail's fine, tail's fine, tail's fine. The other little issue we have is that. It's the fact that we're not supposed to be able to move back on ourselves, because you can't do that in Snake. Luckily, it's also a reasonably easy fix. In inputs, these two move up and down, these two move left and right. So we should only move up and down, or we should only read the inputs for up and down if we are not currently moving up or down. In other words, our Y direction is 0. So if, and we're looking at Snakehead, because that's the direction we're currently moving, dot Y is equal to 0, then we read these inputs. Oop, one too many. And if Snakehead dot X direction is equal to 0, then we have the ability to move left and right. That's it. Now, this sets the new direction. What's a dir new? Which means if I press up and we set dir new, and I press down before our direction actually changes, it will still read the other input. So if you press the wrong button or you change your mind in the 7 frames, the 10th of a second before it actually changes direction, you can still change it, which means it'll still feel kind of responsive, even if your actual direction change only happens slightly after you press it. And now if I try to press down, nothing happens. If I'm going down and I press up, nothing happens. I'm going to the right and I press left, nothing happens. If I'm going left and I press right, nothing happens. We're also going to have to do something about this. The fact that the snake can leave the playfield. And probably the colors and stuff. But we'll deal with that later. Okay, what I actually want to do in this episode is add some fruit. So, the first thing we're going to need is a big table to hold all the fruit. For now, let's just add an entry in here, make a new object, and the object is going to have an X position of 10 and a Y position of 10. Okay, but that doesn't do anything yet, so let's draw something that we can draw to screen. Let's make it orange. I don't know. Oops, draw to. Let's just make a square. And then we need to draw it. So in draw, we want the fruit to be below the snake so that the snake moves over it. So after drawing the grid, we're going to draw fruit. Now we might as well do this for all of them now, so that when we do add extra fruit, I don't know, maybe later on we'll have extra fruit on screen, more than one. We can add them either when the previous one is taken or on a timer where, you know, it adds them after X number of seconds and the uncaught one expires after X number of seconds. We can decide which format we're going to do. The easiest would just be to have one fruit on the screen, and when you eat it, then a new one pops up. So that's probably what we're going to go for. But either way, for index and fruit in pairs, can our fruit be pairs? It can be anything. Pairs for fruit 2, and we're going to draw a sprite. The sprite is 288. We can add variation and extra ones to that after a while. The position is going to be f dot x position and f dot y position. Our transparency color is 0, and then scale is 1 and all that nonsense, so we don't have to pass that. But this needs to be in pixel space, so we need to pass this to grid. That little function is coming in very handy. And run it. And it works. Okay, but we don't want to add it in the declaration. We want to add it at runtime. So we can probably do this after a slight delay. I don't know, is there a fruit on screen immediately when Snake starts? I'll do some research. But in here we're going to just add a new function called newFruit. And then we're going to write and then we're going to write that function. I can words, I promise. So under new segment, we're going to make a new one called newFruit. It's not going to take any variables because we're going to calculate everything in here. So what we want to do in here is, in order, first list of all available cells, remove the cells occupied by the snake, pick a random cell from that list, and then return. Do we want to return the value? No. Add fruit to location. That's what we need to do. But the first thing is this part, remove snake cells. To be able to do that, we need to... Oh, I'm coding this in the middle of a function. My tabbing is weird here. This and all of this. What? If. So all of these need to be tabbed in. There we go. This is the end of new segment, and then below this we have our little function. Okay. So there's our grid helper, there's our debug trace. So let's make a new function and call it occupies. It's going to take a table, x position and y position. Returns true if the table has a entry that what's the thing for? There we go. Okay, that's what it does. So if we pass this, for instance, snake with 2 and 15, then it goes through snake, and if it finds one where the x position of 2 and the y position of 15 exist, it means this table has an object in that location, so the location is occupied, which is why it's called occupies. Occupies because this table occupies that position. That's the thinking anyway. So for I and v in table, table is a reserved word. Let's just call it object do and if v dot x position is equal to x position and v dot y position is equal to y position, then return true. Then if it's gone through this entire list and it comes out of the for loop and we haven't found one that contains that position yet, we just return false. Okay, so that's called occupies. It'll make sense why I'm doing it in this order in a second. So now in new fruit, first we need to list all the available cells. Local avail cells is equal to an empty list. Then for I use iterator I a lot. Starts at, so we're going from 1 to 18 horizontally and vertically. So 18 cells across, 18 cells down, that's 324. So I can take a single integer and break that into an x and a y. That's probably the easiest. So if we start at 1, no, you know what? We start at 0. We go until we hit grid size times grid size. And we're stepping at 1, so we don't have to add this part. Avail underscore cells. This will be a table.insert. I can theoretically just set a particular index of the list to I. Is that a good idea? Okay, here's what we're going to do. Oops, I knocked something over. Here's what we're going to do. Local let's call it potential fruit is going to be a new object, and the object is going to have let's put this into a new line. Y position is going to be -I divide by grid size. The double means we're rounding down, and x position is going to be I modulo grid size. So I is going to run from 0 to 324. Each one of those numbers is going to represent one cell across this grid. So that's 0, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, all the way up to 17. Then y would tick up to 1. So then 1 times grid size means 18 plus 0. So that's 18. That would be 19, 20, 21, 22, 23, 24, all the way until we hit 323 down here. That's the idea. That's not going to work though. Why is that not going to work? Because this little change I made in our grid function, minus cell size, means that our grid actually starts at 1, top left corner. We need it to start at 0. If we take that out, it realigns the entire grid to start at 0, top left corner, because now the x and the y axis translates to be from 0. And the only place that this is going to affect things is that our starting snake is now one cell too low. So we just move this to 14, 15, 16, and 17. Okay, back to new fruit. So this should now give us okay, I'm going to do two things here. Debug trace available cells, and we're going to output the length of avail cells. Now, for this to show up, because this runs first thing, we need to actually start the game in debug mode. So let's just set debug mode to true, which means if I run it, we are in debug mode, and if I now press escape, why is this calling over and over and over and over? Oh, because it's inside the for loop. Either way, we end at 325? Is that correct? Yeah, 318 by 18, I don't know. Where does it start? It starts at 1. Why does it start at 1? Did I tell it to start at 0? I told it to start at 0. So oh, because they were printing the length of this, so we've added 1 already. Okay. We actually need this outside our for loop, so that we only get a trace of the final result, like that. Let's just quickly clear this, and then run it, and stop it. There we go, available cells, 325. And they should all have an X and a Y. But now we need to remove the cells that belong to the snake. So when we hit a particular, actually let's move this to here. And then this is just going to take the value of X position. And this is going to be Y position. Like that. The reason I'm doing this is because if occupies snake, if the snake occupies X position and Y position, if not, if the space is not occupied, then we can add it to our table. Otherwise, we just continue with the loop as normal. Snake not in this spot. Problem is, every time we generate a new fruit, we have to recalculate this, because the snake will be in a different spot every time. But theoretically now we should have 321, because our snake is 4 sets long. Unless I broke it. Attempt to call a null value traceback snake. 282, 282. What's at 282? 271. I passed it the object, didn't I? I didn't test this. Did I mention that I didn't test this? Oh, in pairs. Ugh, rookie mistake. There we go. 321. Cool. It has successfully removed the 4 cells that our snake occupies. That error message is giving me anxiety. So that's remove snake cells is done. So snake not in. Okay. So we have a list of all available cells. Then we remove the snake cells. Then we pick a random one out of this list, because they're all viable. So we can, I was going to just return it and then create it somewhere else, but theoretically what I can do is just go local selected is equal to math.random. So it's going to pick as a random integer between 0 and the length of available cells. That gives us a number, which means we can then go table.insert to fruit the object that's in avail cells at the index that was selected. Straight into the fruit. Which means now our app starts up. Oh, this. Should be here. Our app starts up, it shows us the available cells. Well, traces the available cells. Then it selects a random one. Debug trace selected. You know, I can tweak debug trace to just take a string value and a variable and concatenate them automatically, but then I limit its functionality, so I'll just concatenate it manually every time. Selected. And then for the hell of it, I can also debug trace basically this dot x position followed by a comma followed by the same thing but the y position, just so we can see what the position is that we selected and added, and close parenthesis. Okay, run it. Of course I broke something. String 274, attempt and index a number value field question mark. 274 is the line I'm on. Avail cells selected. Huh? Avail cells exists there. For if not occupies table. Okay, so when it hits available cells, we have a number, then it selects 250, and then it gives me the error at 274. Oh, dot x position and dot y position. Still same error message. But we know each potential fruit. Oh, because we're just inserting I. We're not inserting potential fruit. There we go. Cool, that has a location. And every time I refresh it, it should be somewhere else. Look at that. And it'll never pick one that's underneath the snake. Cool. Okay, so next up, we need to be able to catch this little thing, which we're also going to use our occupies function for, because that's the beginning of collision detection. Why can I not speak today? Let me take out all these debug traces. Snakehead can stay in. It's a new fruit. This stuff can come out. Okay. So pick a random from the list. That goes there. And then add fruit to location. There we go. Okay. Next one, we're starting with collision detection. We're going to print the score to screen so that we can see that we actually caught the thing. And then I'm going to do some other little nifty details. And we should probably draw some fruit at some stage. Ugh, I'm bad at art.